Forget polished workshops and advanced robotics. What you are about to witness is a masterclass in raw battlefield engineering. The initial problem: a Class 1 vehicle recovery with no specialized equipment. The vehicle's dead weight is compounded by the powerful hydrostatic pressure of the stream. Here, the primary tools are leverage, determination, and an intuitive grasp of fluid dynamics. But this is not just a recovery, it's the beginning of a complete resurrection. She attempts to find a stable anchor point on the chassis, testing the vehicle's structural integrity under load. Each attempt to manually dislodge the vehicle is a data point, assessing friction and soil mechanics. The arrival of a second operator doubles the applied force, but the core problem of traction remains unsolved. They coordinate their efforts, trying to create a harmonic oscillation to break the suction of the mud. The solution arrives: a prime mover. The tractor introduces a significant mechanical advantage. The critical step: securing a tow line to a load-bearing point on the car's frame to prevent tearing. A slow, steady application of torque is essential. Too much force could shear the axle or damage the transmission. The vehicle is free from the water, but now the challenge is the high shear strength of the saturated soil. The team combines the tractor's pull with a manual push, adding vectors of force to overcome the remaining resistance. Each foot gained is a victory against the terrain's immense frictional and gravitational forces. As night falls, the operation continues. The urgency suggests the vehicle is critical for transport. The tow continues under low-light conditions, a hazardous procedure on uneven ground. The tractor operator navigates by the narrow beam of the headlights, relying on experience. The recovery is complete. Now, the damage assessment and true engineering work can begin. Phase 2. Diagnostics. A full systems check is required after severe water and sediment exposure. The vehicle is repositioned to a makeshift workshop. The ambient light suggests the start of a new day. The location provides better access to tools and a more stable environment for the complex repairs ahead. Our engineer begins her work. Her posture indicates she's inspecting the undercarriage for damage. First critical task: draining the engine oil. This is a diagnostic test, checking for water contamination. She opens the engine bay. A visual inspection of the block and manifolds for cracks is the next logical step. New lubricant is added. This is vital to prevent seizure in an engine potentially compromised by debris. Her meticulous work on the front assembly suggests an issue with the steering linkage or radiator mount. A test start: she listens to the engine's acoustics, diagnosing issues with timing, compression, or bearings. An incredible display of ingenuity, using a simple Class 1 lever and fulcrum to lift the vehicle's frame. She supplements the lever with a mechanical screw jack, a much safer method for sustained elevation. With the wheel lifted, she can now inspect the entire suspension assembly and braking system. The lug nuts are removed. Her efficiency suggests this is a familiar, well-practiced procedure. The wheel is removed, exposing the hub, brake drum, and critical suspension components. The replacement tire is fitted. She ensures it is seated correctly on the hub to prevent dangerous vibrations. An impact wrench is used to torque the lug nuts, applying uniform pressure to secure the wheel. The vehicle is lowered. The repair must be duplicated on the other side to ensure balanced handling. Now, a more complex task: dismantling the shock absorber assembly. This is vital for ride stability and safety. She carefully disassembles the components, likely to replace a worn bushing or a failed hydraulic seal. This is where art meets engineering, field welding a critical suspension component. She must achieve perfect penetration without compromising the tempera of the surrounding high-tensile steel. The welding mask is essential PPE, protecting her from UV radiation and molten metal spatter. The brilliant blue of the arc indicates a high-temperature MIG or arc weld, suitable for structural steel. With the part repaired, she begins reinstallation. Alignment must be precise to factory specifications. Each bolt is threaded by hand to prevent cross-threading before being tightened to the correct torque. She moves to the rear suspension, using an angle grinder or power wrench to remove a corroded bolt. An impact driver makes quick work of the wheel removal, a testament to having the right tool for the job. A manual wrench is now used for a component, requiring more finesse and tactile feedback. The reassembly process, swift and confident. Her workflow is optimized for efficiency and accuracy. Another improvised solution, a wooden beam acts as a cheater bar, multiplying her force to break a stuck seal. Attention now shifts to the bodywork. She begins removing the rear bumper assembly. Next, the front bumper is detached, likely to grant better access to the engine frame or radiator. This appears to be surface preparation, perhaps for rust treatment or a new coat of protective paint. A stark contrast, this brief interlude highlights the serene, natural environment of her work. But the challenges are never far. Here, another piece of vital machinery is disabled by the terrain. She attempts a solo recovery, analyzing the forces needed to move the immense weight of the tiller. She works methodically, trying to dislodge one section at a time, rather than fighting the entire mass at once. Her persistence is a key engineering trait. If one method fails, analyze and try another. This is a battle of persistence against inertia and the powerful grip of saturated clay. The exposed engine is vulnerable to severe water damage, making the recovery effort time critical. A new day, a new project, the story of relentless ingenuity continues with another machine. This tiller's exposed engine shows signs of being bogged down in heavy, cohesive mud. Her first step is to clear the mud, which acts as a concrete-like anchor and prevents heat dissipation. She opens the engine housing to assess the extent of the internal contamination. A high-pressure water stream is used to flush fine sediment from the delicate engine components. Meticulous cleaning is not just aesthetic, it's a crucial diagnostic step to reveal hidden cracks or damage. Every piece of equipment must be moved manually in this challenging and stable environment. Partial success, the tiller has been moved, demonstrating a successful application of force. The machine is now clear of the water, mitigating the immediate risk of further water ingress. Again, a larger prime mover is brought in. This is a recurring theme, escalating the available power. A tow rope connects the two machines. The tensile strength of this rope is now the system's weak point. It's a delicate operation, requiring communication and coordination between the two operators. The blue tiller is now acting as a deadweight sled, being pulled through the high-friction mud. The recovery, successful. Both machines are on relatively stable ground. A wide shot reveals the scale of the operation within the vast, rural landscape. The red tractor moves off, its primary task of providing motive force now complete. The blue machine is now being towed back to the workshop for its own intensive care session. Towing a vehicle with no power, especially on dirt roads, is a test of skill for the tow operator. The camera focuses on the towed machine, highlighting its status as dead weight. The journey ends, and the process of diagnostics and repair is set to begin once more. The post-recovery cleanup is a critical first step, preventing corrosion and allowing for a clear inspection. Pressurized water is effective for removing caked on clay and organic matter from the chassis and wheels. Now, the engineer returns to her element. She begins a systematic check of the blue tractor. She's draining the oil. The dark, viscous fluid suggests it's overdue for a change or contaminated. She carefully collects the used oil, ensuring no environmental contamination. The drain plug is replaced and tightened, a simple but critical step to prevent leaks. A full toolkit is deployed. She has everything needed for a comprehensive mechanical and electrical diagnosis. She appears to be cleaning a surface, perhaps to inspect for a hairline crack in the engine block. Inspection of the hydraulic lines. A leak here would mean a complete loss of power for any attachments. Refilling with fresh oil. The lifeblood of the engine is carefully measured and poured. This could be an adjustment of the valve clearance, a fine-tuning that impacts engine performance. She inspects the battery terminals. A poor connection here is a common and easily fixed point of failure. The work continues with focus and precision. Each part is checked, cleaned, or adjusted in sequence. Her hands move with the confidence that comes only from countless hours of practice and experience. Rain begins to fall, but the work does not stop. The mission to resurrect the machine is paramount. This systematic approach ensures that no potential fault is overlooked before attempting a restart. From the fuel system to the electrical circuits, every component is being methodically verified. Her focus is absolute, tuning out all distractions to commune with the intricate language of the machine. This is a portrait of expertise in action, a deep-seated knowledge applied with practical skill. The final checks are being made. Soon, the moment of truth will arrive, the attempt to start the engine. The scene resets on another project, showcasing the versatility of her engineering skills. She's working on the fuel injector or spark plug, a precision task that governs the engine's combustion cycle. A close-up inspection is needed to diagnose the subtle signs of wear or malfunction. Again, she works on the ground, showing her willingness to do whatever it takes to access the problem area. The machine is moved undercover, perhaps to protect the exposed engine parts from the elements. The narrative shifts, showing her in a different role, transporting raw materials, the purpose of these machines. And here we see the cause and effect, a vital machine, immobilized, halting the workflow of the farm. She enters the water herself, a direct, hands-on approach to solving a complex physics problem. She exerts force, trying to find the path of least resistance to pivot the machine out of the stream. Clearing debris from the machine is the first step, reducing drag and preventing further mechanical damage. This is a sheer test of strength, pitting human power against the dead weight of waterlogged steel. Assistance arrives, the problem now becomes one of coordinated effort and synchronized force. A moment of rest, the machine is partially free, a sign that their strategy is working. Success, the tractor is on dry land. Now begins the familiar process of damage control. A post-recovery inspection is crucial to assess the damage caused by the submersion. She meticulously cleans the machine, a process that is both restorative and diagnostic. A final check of all systems is performed before any attempt is made to restart the engine. The machine, clean and inspected, stands as a monument to her skill and persistence. The engine turns over, a successful resurrection, achieved through expert knowledge and sheer will. Back in operation, the engineer is now the operator, completing the cycle from problem to solution. The work is never truly done. Each machine represents a new puzzle, a new test of her abilities. The men struggle, their raw power insufficient to overcome the immense forces at play. The woman provides strategic support, likely directing the force to the most effective pivot point. Once again, the solution is mechanical advantage. A more powerful machine is brought in to do the heavy lifting. The team works in concert, guiding the machines through the treacherous, high-torque maneuver. She takes the helm of the disabled vehicle, steering it carefully as it's pulled through the rushing water. The machine nears the bank. The most dangerous phase of the water crossing is almost over. Both tractors are now on the road, the recovery, a success due to teamwork and proper equipment. The journey back to the workshop begins, a slow and steady tow to the place of repair. The red tractor provides the motive force, its engine easily handling the weight of the second machine. The path is uneven, requiring skillful driving to prevent the tow rope from snapping or tangling. They arrive at the workshop, a hub of constant engineering activity. The operator of the tow vehicle dismounts. Is part in this phase of the operation complete? Our lead engineer arrives on the scene, ready to take command of the technical diagnostics and repair. An initial diagnosis reveals the problem: a severely damaged radiator, critical for engine cooling. She immediately begins the repair, her focused expression indicating she has already formulated a plan. This is delicate work. The radiator's thin cooling fins are easily damaged and require a steady hand. Her movements are precise and economical, wasting no effort as she works to restore the component. The professionalism on display rivals that of any formally trained mechanic in a modern facility. She has entered a state of deep focus, where the only things that exist are her tools, and the problem to be solved. We now observe a complete engine overhaul, the most complex of mechanical tasks. She collaborates with a partner, a common practice, in engine teardowns for safety and efficiency. Now working solo, she begins the painstaking process of reassembling the engine's core components. She removes the damaged radiator, which is corroded, and clearly the source of a major coolant leak. The leak is confirmed. Without this part, the engine would overheat and suffer catastrophic failure in minutes. She begins the repair, first cleaning the surface, to ensure a strong bond for the patch material. A wire brush is used to remove oxidation, a critical preparation step before any welding or brazing. She applies heat and solder to seal the leak, a high-skill repair that requires precise temperature control. While the radiator cools, she moves to another component, demonstrating an efficient, parallel workflow. The repaired radiator is now ready for reinstallation back into the main tractor frame. This engine component is coated in thick, burnt-on oil, a sign of a significant internal leak that must be found. She dons safety glasses to begin welding, this time on what appears to be a cracked engine casing. This is an advanced level repair. Welding cast iron requires specialized rods and techniques to prevent cracking. The bright shower of sparks indicates she is likely using an arc welder for this structural repair. She lays a careful bead, stitching the metal together with molten steel. The weld is almost complete. The part will need to cool slowly to reduce stress and prevent fractures. A quick visual inspection of the finished weld before moving on to the next critical repair. She applies her welding skills to another area, demonstrating the widespread nature of the required repairs. Each repair strengthens the whole, bringing the machine one step closer to operational status. She examines her work with a critical eye, satisfied with the quality and integrity of the repair. The hot sun and challenging conditions do not deter her. The work continues with unwavering focus. Her workspace is the earth itself, littered with the tools and components of her trade. This close-up reveals a harsh reality of field repairs, fighting against rust, grime, and material fatigue. She works on the exhaust manifold. A leak here can reduce engine power and release dangerous fumes. A precision tool is used to make a fine adjustment, likely on the fuel pump or carburetor. The scenic background is a stark contrast to the intense, focused, and greasy work in the foreground. The L-shaped tool is likely a hex key, used to access a bolt in a tight, hard-to-reach location. She uses a wrench to apply final torque to a bolt, ensuring a secure, vibration-proof connection. The cylinder head cover is removed, exposing the engine's brain, the valve train. Here we see the rocker arms and valve springs. She will inspect these for wear and proper clearance. The disassembled parts are laid out in order, a crucial practice to ensure correct reassembly. She cleans each component in a solvent bath, removing sludge that could impede oil flow. This cleaning process is tedious but absolutely essential for a successful engine rebuild. Reassembly begins. The clean, repaired parts are carefully installed back into the engine block. The entire area is a hive of activity, a community that relies on these machines and the skills to fix them. This montage signifies the complexity and number of individual components that make up a single engine. Each part is installed with care, torqued to spec, and checked for fit and function. A new fuel filter is installed, a simple replacement that can solve a wide range of performance issues. The work is done. Her expression is one of quiet pride and confidence in a job well done. This is not just a mechanic, this is an engineer, a problem solver, and a master of her craft. The final sequence, meticulous cleaning of the reassembled engine before the first test. She makes final adjustments to the fuel and air mixture, tuning the engine by sight, sound, and feel. Her knowledge is comprehensive, spanning every system of the machine from the engine block to the chassis. Coolant is added. The fin indicates they are simulating airflow to test the cooling system. She improvises a funnel, another small example of the resourcefulness that defines her work. She takes the operator's seat, ready for the moment of truth, the culmination for long hours of work. Simultaneously, work continues underneath, a reminder that the job of an engineer is never truly finished. She gives the engine one last check, ensuring all her repairs are secure before applying starting power. She braces the machine, anticipating the torque and vibration of the engine turning over, a final, heroic effort. A very special thank you to the owner of the YouTube channel Etuna for creating this wonderful video and allowing me to comment. If you enjoy this narrative, please visit and support their channel at the link in the description below.